we're going to talk about function notation and how to evaluate functions. This is extremely similar to evaluating expressions that we did at the beginning of the year. So it really should just be kind of a refresher. Function notation, basically it's very, very simple. Up to this point, when we've written equations, we've written them as y equals something. With function notation, we're going to use this symbol, f and in parentheses x, and it's pronounced f of x. And it can be any letters. It can be g of x. It can be f of y. You can use any letters for f of x. But we're going to use this in place of y. You use function notation to prove, or if something is written in function notation, you can automatically assume that that equation, that table, that graph that goes along with that equation that's written in function notation is a function, that it passes the vertical line test, that it only has one domain to each range, or one range each domain. It is a function. If it's written in function notation, it is a function. Alright, so for example, we have an equation written, f and y equals 3x minus 8. So right in the function notation, you just write f of x equals 3x minus 8. Whatever variable is in the equation, that's what you got to use in the parentheses. So if that would happen to be 3y minus 8, you would do f of y. And just like I said last slide, function notation tells you that the equation is a function, and it passes the vertical line test. It passes the vertical line test for the graph that goes along with that equation, 3x minus 8. That's all function notation is, just tells you it is a function. Evaluating functions, very similar to evaluating expressions that we did beginning of the year. To evaluate a function, we're going to replace the variable with the number that is inside the function notation. So whatever number is inside the parentheses, we're going to take that and replace it with replace the variable with that number, and then we're going to use order of operations to simplify it. All right, so take the number that's inside the parentheses to replace the variable with it, and then use order of operations to simplify it. So our examples here, we have f of x equals negative 7x plus 4. And we want to find out what this function would equal if we find out f of 2. So what we're going to do, we're going to take out this. We took out this x and replace it with 2. So that means we have to take out this x and replace it with 2 also. All right, then order of operations, multiplication first, negative 7 times 2. Negative 14, negative 14 plus 4 is negative 10. So therefore, f of 2 is equal to negative 10 in that problem. And if we look at the second example, we have f of x equals, that's x squared minus 2x. And we want to find out when x is 5. So we're going to take out all these x's and plug in 5. So f of negative 5 would be negative 5 squared minus 2 times negative 5. So order operations, we do parentheses, or we do exponents first. So negative 5 squared is 25. And we can go ahead and do negative 2 times negative 5 is 10. So then f of negative 5 And 25 plus 10 would be 35. So f of 5 would equal 35. So for function notation, just replace the variable that's in the parentheses with that number. And function notation means it is automatically a function.